Number 2, q of x equals x divided by x minus 1, x plus 2. In this problem, we are going to do the same thing that we always do and start with the domain. So the domain, and that is determined by looking at the denominator. Sorry, the camera's doing some funny things. That is started by looking at the denominator, our x minus 1, x plus 2. We take that denominator and we set it not equal to 0. So in this case, because the denominator is already in a factored form, we can immediately just say that x cannot equal 1, x cannot equal negative 2. Looking at our original equation in factored form, doesn't change it at all, so I'm going to rewrite it. Nothing can cancel top to bottom, so we know that both of these are vertical asymptotes. So we have a vertical asymptote at 1 and a vertical asymptote at negative 2. There are no holes. Because the degree of the denominator is greater than the degree of the numerator, we know that there is a horizontal asymptote at y equals 0. The numerator, the x-intercepts are determined by looking at the zeros of our numerator. Our numerator is just plain x, so x equals 0. And that will also actually, because if x equals 0, the ratio of constants, there is no constant up top. In the bottom, the constants are negative 1 and 2. So the y-intercept is that same 0, 0 point. So that's everything that we need in order to graph this thing. So we're going to go over here and make a graph. We'll put vertical asymptotes at 1 and a vertical asymptote at negative 2. Since there are no holes, the degree of the numerator is greater than the denominator is greater than the degree of the numerator. That tells us that we have a horizontal asymptote on the axis. X-intercept at x equals 0. Y-intercept, well, that's the same thing. So this time we're left with a graph that looks like this, and now we've got to figure out how to put in the different pieces. So we know, starting with the middle, this either has to go like this or like that. We know that because there is only one x-intercept and its multiplicity is odd, so we know that it cuts through. So I'm going to take this negative 1 point, I'm going to plug negative 1 back into my equation, and all I'm looking for is a sign here. Am I above or below the x-axis at negative 1? So when I plug that negative 1 in, right, the top is negative, negative 1 minus 1. Negative 1 minus 1 is negative. Negative 1 plus 2 is positive. So at negative 1, negative negative makes positive. We are up here. Because we are up here, we are positive. We can only go like this. And then it will come down and flatten that way. So there's the middle piece. Now we have to determine what our ends look like. Since there is no x-intercept, we're either going to stay completely above the x-axis or below the x-axis in each one of those cases, either completely above the x-axis or below the x-axis. So again, if I go negative 1, negative 2, negative 3, go out there somewhere. And again, I'm really just concerned with what the sign is. So if I plug in negative 3, the top is negative. Negative 3 minus 1 is negative. Negative 3 plus 2 is negative. 3 negatives leave us negative. So over here we are below the x-axis. So I know I'm going to look like this on that side. Last step, I plug in a positive number. 1, plug in 2. Again, just looking for sign. We're going to be positive. We're going to be positive. We're going to be positive. And it looks something like this. So there is the graph and the answer to number 2.